Hello friends, my name is Mr. A.R.Savalwade and today I am going to teach you Strength of Material subjects, which is your third semester. Today I am going to teach you the properties of materials, which is very important topic. Before going to design any product, we should know the properties of materials so that we can select best suitable material while designing any product. Introduction. In practical applications, the of engineering materials in manufacturing engineering depends upon a thorough knowledge of their particular properties under wide range of conditions. The term property is a qualitative or quantitative measure of response of materials to externally imposed conditions like forces and temperature. It means if we apply force on any body, then they changes their properties. There are mechanical properties, some chemical properties. Now we are going to study few mechanical properties of them. Mechanical properties. The properties of material that determine its behavior under the applied force are known as mechanical properties. Means when you apply any kind of force, tensile force, compressive force, there is some change in a body or material, and that changes is known as a mechanical properties. They are usually related to elastic and plastic behavior of material. In that there are two terms, elastic and plastic. Elastic means when we apply force on any body and remove it, it does not undergo any kind of a deformation. That means there is no change in size and shape. Plastic means there is some permanent deformation. That means there is a change in length or change in diameter or change in size. It happens. These properties are expressed as function of stress and strain. A sound knowledge of mechanical properties of material provides the basic for predicting behavior of materials under the different load conditions and designing the components out of them. Now we are going to discuss first property, strength. The strength of a material is its capacity to withstand destruction under the action of external loads. Strength means nothing but it is the ability of that material to sustain the force without its failure or before failure. It determines the ability of material to withstand stress without failure. The maximum stress that any material will withstand before destruction is called as ultimate strength. Means आपण कोणत्याही बॉडीवरती मॅक्सिमम स्ट्रेस किंवा मॅक्सिमम फोर्स अप्लाय केल्यानंतर जो तो आपल्याला स्ट्रेस मिळतो त्या स्ट्रेसला आपण मेन्शन करतोय अल्टिमेट स्ट्रेंथ. इलास्टिसिटी. Elasticity, the property of material by virtue of which deformation caused by applied load disappears upon removal of load. It means if we apply force on any body and removes it, the body regains its original shape and size. म्हणजे कोणत्याही बॉडीला आपण जर फोर्स अप्लाय केल्यानंतर काढून घेतला तर ती बॉडी आहे त्या शेप आणि साईजमध्ये परत येते. त्याच्यामध्ये कोणत्याही प्रकारचे डिफॉर्मेशन म्हणजे चेंज इन लेंथ, चेंज इन डायमेन्शन्स आपल्याला मिळत नाहीत. त्या प्रॉपर्टीला आपण मेन्शन करतोय इलास्टिसिटी. इलास्टिसिटी ऑफ अ मटेरियल इज द पॉवर ऑफ कमिंग बॅक टू इट्स ओरिजिनल पोझिशन आफ्टर डिफॉर्मेशन when the stress or load is removed. आता या डायग्राममध्ये तुम्हाला क्लिअरली दाखवलेलं आहे. पहिल्या केसमध्ये तिथे कोणत्याही प्रकारचा बॉडीवरती फोर्स अप्लाय केलेला नाही आहे आणि जे मॉलिक्युल्स आहेत ते नॉर्मल कंडिशनमध्ये आहेत. दुसऱ्या डायग्राममध्ये आपण फोर्स एफ अप्लाय केलेला आहे. फोर्स एफ अप्लाय केल्यामुळे त्या बॉडीची इलॉंगेशन आपल्याला डेल्टाने मिळते आणि त्या मॉलिक्युल्समध्ये स्ट्रेचिंग आपल्याला दिसतो. रेड कलरमध्ये त्यांनी ते शो केलेलं आहे. आणि थर्ड केसमध्ये आपण फोर्स रिमूव्ह केल्यानंतर बॉडी आहे तशीच आपल्याला ओरिजिनल शेप अँड साईजमध्ये आपल्याला त्याच्यामध्ये मिळालेली आहे, म्हणजेच ती बॉडी इलास्टिक आहे. या डायग्राममध्ये पण तुम्हाला क्लिअर होतं. स्प्रिंगचं एक्झाम्पल त्यांनी घेतलेलं आहे. स्प्रिंगमध्ये बिफोर लोडिंग मीन्स नो लोड इज अप्लाइड. सेकंड कंडिशनमध्ये ड्युरिंग लोडिंग force is applied, then spring gets compressed. Therefore, length of spring is reduced. After load is removed, again spring comes back to into its original position. That is free length of spring. Next property is plasticity. The plasticity of a material is its ability to undergo some degree of permanent deformation without rupture or failure. Plasticity means when we apply force on any body and removes it, it goes some permanent deformation without failure. That means there is some change in length, change in dimensions or size. Plastic deformation will take only after elastic limit is exceeded. It increases with increase in temperature. Means plasticity increases with increase in temperature. If there is a maximum temperature, then body readily goes into the plastic state. सिमिलरली याच्यामध्ये तुम्हाला 3 डायग्राममध्ये क्लिअर केलेलं आहे. फर्स्ट कंडिशनमध्ये नो लोड इज अप्लाइड. सेकंड कंडिशनमध्ये फोर्स अप्लाय केल्यानंतर बॉडी स्ट्रेच झालेली आहे डेल्टाने. आणि थर्ड कंडिशनमध्ये लोड रिमूव्ह केल्यानंतर परत त्याची काहीतरी तुम्हाला डेल्टा प्लास्टिकमध्ये शो केलं आहे. म्हणजे देर इज अ समथिंग चेंज इन लेंथ. दॅट चेंज इन लेंथ बिकॉज ऑफ प्लास्टिसिटी प्रॉपर्टी. अँड प्लास्टिक मीन्स परमनंट डिफॉर्मेशन. Next property is stiffness. The resistance of material to elastic deformation or deflection is called as stiffness. That means resistance offered by the material within elastic limit is known as the stiffness. A material which suffers slight deformation under load has high degree of stiffness or rigidity. Example, steam beam is more stiffer or more rigid than aluminum beam. Stiffness is nothing but ability to sustain the force within the elastic limit. Next property is ductility. It is a property of material which enables it to draw out into thin wires. Means the property of material which can be drawn into small thin wires. For example, mild steel ductile material. The percentage of elongation and reduction in area in tension is often used as empirical measures of ductility. हा डायग्राममध्ये तुम्हाला शो केलेला आहे. कोणताही एलिमेंटला जर तुम्ही टेन्साईल फोर्स अप्लाय केला तर त्याची जी डायमीटर आहे रिड्यूस होते. ते तुम्हाला फर्स्ट स्टार्टिंग पॉईंट आणि एंड पॉईंटमध्ये दिसतं डायग्राममध्ये डक्टिलिटी टेस्टमध्ये. आणि सेकंड तुम्हाला दिलेला आहे डेफिनेशनमध्ये मेन्शन केलेलं आहे एनेबल्स इट टू ड्रॉ इन टू थिन वायर्स. म्हणजे जे आपण वायर मॅन्युफॅक्चरिंग करतो आहे, वायर मॅन्युफॅक्चरिंग करत असताना त्या वायरची प्रॉपर्टी असली पाहिजे, त्या मटेरियलची प्रॉपर्टी डक्टाईल. इट शुड बी डक्टाईल. देन इट कॅन बी एबल टू ड्रॉ इन टू थिन वायर्स. नेक्स्ट इज malleability. Malleability of material is its ability to flatten into a thin sheets without cracking by hot or cold working. It means thin sheets. For example, you have to manufacture a steel plate or anything like thin sheets, then that material should have malleability property. Then we can easily manufacture small thin sheets, cast iron sheets, etc. etc. Example, lead can be readily rolled and hammered into thin sheets but can be drawn into wires. Comparison of ductility and malleability. In ductility we mentioned it should require a tensile force to drawn into wires, and in malleability we should require hammer it, means compressive force. Ductility is a tensile quality while malleability is a compressive quality. Resilience. It is the capacity of materials to absorb energy elastically. The maximum energy which can be stored in a body up to elastic limit is the proof resilience, and the proof resilience per unit volume is called modulus of resilience. Resilience means nothing but ability to sustain shocks and vibrations during working conditions. Most of the parts working conditions, it absorbs shocks and vibrations. At that time they should not fail. They in working conditions. Therefore, machine parts should have resilience property. Hardness. Hardness is the fundamental property which is closely related to strength. Hardness is usually defined as the ability of material to resist to scratching, abrasion, cutting, indentation, or penetration. The methods for used to determine hardness of a material are Brinell hardness test, Rockwell hardness test, and Wicker hardness test. Hardness is nothing but ability of material to resist scratch, abrasion, cutting, indentation, and penetration. For example, glass, diamonds, they are hard materials. Next property is brittleness. It is the property of material breaking without much permanent distortion or permanent deformation. Non-ductile material is considered to be a brittle material. It means brittleness means it will not give any prior notification before its failure. It suddenly fails. For example, if you take a glass, if you apply a force or apply a load on glass, it directly breaks. It will not give any prior intimation before its failures. If you take wood, wood is also a brittle material. It will suddenly breaks. But if you take a steel or other metals, it they have less brittleness property. Creep. The slow and progressive deformation of a material with time constant stress is called creep. Depending on temperature, stresses even below the elastic limit can cause some permanent deformation. It is most generally defined as time-dependent strain occurring under stress. It means slow and progressive deformation of a material under stress in temperature. That means if you are applying the stress on a body and that body is under temperature for longer period, then there is some change in length or change in dimensions due to stress and temperature. That is known as a creep. म्हणजे कोणताही एलिमेंट जर तुम्ही घेतला त्याच्यावरती फोर्स अप्लाय केला आणि तो एलिमेंट टेम्परेचरमध्ये असेल तर त्याच्यामध्ये काही वेळानंतर स्लो अँड प्रोग्रेसिव्ह डिफॉर्मेशन मेन्शन केलं आहे. म्हणजेच काय, स्लोली त्याच्यामध्ये काहीतरी साईजमध्ये चेंजेस तुम्हाला मिळत जातील. त्याला आपण मेन्शन करतोय स्लो अँड प्रोग्रेसिव्ह डिफॉर्मेशन. त्या प्रॉपर्टीला आपण मेन्शन केलं आहे क्रेप. नेक्स्ट, फटीग. This phenomena leads to fracture under repeated or fluctuating stress. The fatigue fractures are progressive beginning as minute cracks and grow under the action of fluctuating stress. First we will understand repeated or fluctuating stress. म्हणजेच कोणताही तुम्ही एलिमेंट घेतला त्याच्यावरती रिपीटेड लोडिंग जर आपण अप्लाय केला, मीन्स टेन्साईल कॉम्प्रेसिव्ह, त्यालाच आपण म्हणतो फ्लक्च्युएटिंग स्ट्रेस किंवा फ्लक्च्युएटिंग लोड. तर कोणत्याही बॉडीला आपण जर रिपीटेड लोडिंग अप्लाय केला तर तो कमीत कमी स्ट्रेसमध्ये ब्रेक होतो बिकॉज ऑफ फटीग फेल्युअर. फॉर एक्झाम्पल तर तुम्हाला सांगायचं म्हटलं तर कोणताही तुम्ही वायर घेतला तर त्या वायरला कंटिन्युअसली तुम्ही कॉम्प्रेसिव्ह आणि टेन्साईल फोर्सेस त्याच्यावरती अप्लाय केला तर तो लगेच ब्रेक होतो काही सायकल्स नंतर. त्या फेल्युअरला आपण मेन्शन करतोय फटीग फेल्युअर. हे झाले आपले सगळे प्रॉपर्टीज ऑफ मटेरियल्स. आता आपण पुढे स्टडी करणार आहे टाइप्स ऑफ बॉडीज. डिपेंडिंग अपॉन द रिस्पॉन्स ऑफ मटेरियल टुवर्ड्स द डिफॉर्मिंग फोर्स, द मटेरियल आर क्लासिफाइड इंटू 3 टाइप्स: इलास्टिक, प्लास्टिक अँड रिजिड मटेरियल. Corresponding material properties are elasticity, plasticity and rigidity. त्याच्यामधला फर्स्ट आहे इलास्टिक बॉडी. A body which regains its original shape and size when load is removed is called as elastic body. Example, rubber and metal. For example, if you take rubber, if we apply tensile force on that, it will changes its size, but when we remove the force, it will come back to its original shape and size. It means it will regain its original dimensions. And that body is known as an elastic body. That rubber has no deformation. Such types of bodies are known as an elastic body. Second, plastic body. A body which does not undergo its original shape and size. A body which does not regain its original shape and size when load is removed is called a plastic body. If you take any plastic body and apply a force, then there is some change in dimensions, that is permanent deformation we get. That permanent deformation is known as the plasticity property, and that body is known as the plastic body. Third is rigid body. Body which does not undergo any deformation under the action of external load is called as rigid body. That means on a body, if you are applying force but there is no change in size and shape in that body, then that body we can say that is a rigid body. But practically such types of bodies are not present. There is no body in the universe that is rigid body. Next is load. Load is defined as set of external forces acting on a mechanism or engineering structure which arises from service conditions in which the components work. Means if you are considering any machine, that machine is working under any type of a loading conditions. Tensile forces are there, compressive forces are there, next there are bending stresses are there. These are the types of loads and types of stresses. Common loads in engineering applications are tension and compression. Tension means direct pull. Example, force present in lifting of hoist. That wire should have tension in that. Compression means direct push. Force acting on pillar of a building. If you are considering a pillar of a building, that pillar has a compressive force. Sign convention. नेक्स्ट त्याच्यामध्ये टेन्शन आणि कॉम्प्रेशन अशा दोन प्रकारचे आपल्याला लोड्स असतात. आपण त्याला स्ट्रेस पण म्हणू शकतो पुढे. तर त्याच्यामध्ये आपल्याला साइन कन्व्हेन्शन हा फार महत्त्वाचा असतो. कोणत्याही ऑब्जेक्टवर जर आपल्याला टेन्साईल फोर्स ॲक्ट होत असेल तर तो आपण नेहमी घेतोय पॉझिटिव्ह, आणि कॉम्प्रेसिव्ह फोर्स असेल तर तो आपण नेहमी काय घेत असतो, निगेटिव्ह. नेक्स्ट पार्ट इज टाइप्स ऑफ बॉडीज. देर आर different ways in which load can be applied to a member. Typical loading types are dead or static load, non-fluctuating forces generally caused by gravity. Means dead and static नावामध्येच आहे तुम्हाला डेड वेट. फॉर एक्झाम्पल तुम्ही कोणताही लेथ मशीन कन्सिडर केला तर त्याचा जर तुम्ही बेड बघितला तर तो डेड वेट आहे, कोणत्याही कंडिशनमध्ये तो वर्क होत नाही. Live load. Load due to dynamic effect. Load exerted by a lorry on a bridge. Means for example live load. आता ब्रिज तुम्ही कन्सिडर करता, ब्रिजवरती जर कोणतीही व्हेकल आपण घेऊन गेलो किंवा कोणताही तुम्ही 4 व्हीलर 6 व्हीलर घेऊन गेला तर तो जो काय लोड असतो तो लाईव्ह लोड. किंवा आपण जर लेथ मशीनच्या बाबतीत कन्सिडर करायचं म्हणला तर त्याच्यामध्ये जो आपला स्पिंडल फिरतो तो स्पिंडल आपण काय म्हणू शकतो, लाईव्ह लोड. Impact load or shock load due to sudden blows, that means hammer is the impact load. Fatigue or fluctuating loads, magnitude and sign of a force is changing with time. Sign changes means there is a compressive or tensile. Compressive and tensile, it means positive and negative. Sign changes. that known as a fatigue or fluctuating loads. Thank you.